Hello everybody, it's Nageela here from Cerebrum Studio, and I'll be delivering a talk looking at innovation in computer vision and how it's impacting the aesthetic visual space, and how life as a marketer might change because of it. Before I begin, I would like to get some feedback from the people that, from you guys. I can see there's about 41 of you watching, and I'd like to know a little bit about what you do and what your experience is, so that I can sort of position the talk so that it's most understandable to you. What I really want to do is to sort of demystify some of the interesting stuff, some of the really exciting stuff that's happening in the computer vision, machine learning space that's impacting visual creativity, specifically looking at video and to some extent to images. So let me begin by sharing my screen here. And so throughout the talk, I've tried to make it as visual as possible. I am going to switch between my presentation and some videos, so you can actually see computer vision and machine learning being applied. If already you're wondering what these terms mean, don't worry, because I will give a brief overview of the sort of the technical elements that go about into creating this kind of AI, so that you have understanding, and then I'm going to explain how it's applied to some of the creative space, so you have some understanding about what's actually going on. So then as sort of walk into the future, we will see more and more of this, and when you get to see, you'll sort of understand the context in which this AI is happening, or this computer vision is happening. So let me go ahead and share my screen with you. Sorry, my presentation. And so you should be able to see the presentation now. So obviously this is our Cerebrum Studio, and we work with computer vision machine learning in the video space. And so it's a really interesting position to be in, because I kind of sit in the middle of the creative side of things and the technical side of things as well. And as I mentioned, I'm going to give a brief overview of the innovative landscape when it comes to computer vision and machine learning, or AI, sometimes it's referred to. And really, we are in the fourth industrial revolution, right? The popularity of the internet over these last few decades and the sort of innovation in hardware in the last sort of 15 years, 10 to 15 years, has meant that we're in a very, very new space in terms of the technology that's available to us and what's being built on the technology that's available to us to further enhance our lives. Of course, you know, every time there's an industrial revolution, society changes for the good and for the bad. Economies grow. Each industrial revolution will have its own challenges. I'm not going to cover some of the ethics that are involved in working with computer vision and machine learning. Of course, there are a lot of controversial things, and I'll touch upon some of these, but I'm not going to go into an in-depth conversation about the ethics in what's happening here. But a lot of the companies that I talk about are sort of GDPR compliant, and which means that they have some awareness of what they should and shouldn't be doing in terms of working with computer vision and the sort of products and services that they're giving to marketeers or sort of the general public. So coming back to this fourth industrial revolution, what it means is that we now have, I mentioned, the popularity of the internet, and I mentioned sort of increasingly sophisticated devices, including these things over here, so smartphones. We've got an incredibly powerful computer packed into a mobile phone. You'll know that you can do quite a lot of interesting, useful, entertaining things on your mobile device. In actual fact, most of us are consuming a lot more of our social media interaction on our mobile device than we are on a laptop or a PC. And this has really been possible because a couple of things, actually. So with a smartphone, especially with a smartphone, it's connected to the internet, but also it has a lot of hardware that's packed into it that can give us useful information or captures information around us. For example, it can capture audio, it can capture video, it can capture geolocation. It's got vibration in there, so there's motors in there that can help improve our user experience and certain things. So imagine if you're playing a game and you're using your mobile as your remote control as well. So you get that feedback to let you know that you've been shot, to improve your experience of playing on that game. So mobile devices have become incredibly powerful, but it's not just communication devices. The thing about mobility and hardware is that we find lots of small bits of hardware that are smart and are connected to the internet. We are living in a time of Internet of Things. So you might know, or you might own one of those Amazon Dash buttons that kind of senses your fridge is low on a certain item and orders it from Amazon. So that's a small sensor there that's connected to the internet and connected to your Amazon account. And it's gathering data about what products you do and you don't have. And it's conveying that with your permission to Amazon. So this is the Internet of Things. Everything around us, well, there's a potential for everything around us to be collecting information about us if we give it permission. And then that information can be used to deliver us a better service. So that sort of covers things about how well you like your lighting to be, or how you like your lighting to change during different times of the day, how you like your heating to be, how you like the heating to change through different seasons of the year. So home devices connected in all sorts of ways. And what they're all doing is collecting information about us that's being relayed to the internet. So we're in this position where we have masses and masses of personal data. It's not just the stuff that's collected on social media websites, because we know about the importance, or we know about how important it is for marketers actually to be able to get reliable analytics and user profiles before they decide how they're going to spend the marketing budget. But there's more than that. There's all the data that's being captured around us, and the new technologies that are being built with that data that's being captured. So I say, we live in this age where there's all sorts of data that's being captured around us. It means that we have these large data sets. With these large data sets, we've seen huge progress in the last, again, 10, 15 years in fields of machine learning and computer vision. And these are the terms I mentioned earlier. So strictly speaking, computer vision, so it's a branch of computer science. And computer vision, it's about teaching a machine that has a camera, a machine being your PC or your smartphone. It's about teaching that machine to use the camera, the input that's getting from its camera, to view things like a human does. And that's very easy for me to say, but for a machine, that's a very complicated task, because remember, a machine just sees in binary. All it sees is zeros and ones. So the task or the challenge of computer vision is to try to develop algorithms that help the computer to try to understand what the camera is looking at. And that's a big feat. But over the last 10 to 15 years, we've seen huge progress. And this is really one of the things that has really helped innovation in AI and deep learning to take off. So we've had the advances on the algorithm side, and then we've had the advances in, or we've got sort of huge sets of data to analyze and to extrapolate. And we've got incredibly powerful machines. The likes of Google and Amazon have huge server farms, and you will need these type of server farms to do serious computer vision or machine learning tasks. So you have huge amounts of data that you put through that you process through incredibly powerful machines or servers, and then they output to you some intelligent result. And just to give you an idea of the kind of algorithms that I'm talking about, I'm not going to go into this in any depth, but just to let you know that these algorithms are incredibly sophisticated. In the machine learning space, there are probably 50 really popular algorithms in the deep learning space, which is a subset of machine learning, and which is sometimes more closely referred to as AI. In the deep learning space, there are some, I would say, 20 algorithms, and of those, there are about 5 that are really, really popular. I want to note this to let you know that actually, in this space of machine learning and deep learning, there's a lot of work that's already been done. So in terms of the direction of innovation, it's really open, right? So if you have, and so when software engineers and when data scientists are developing a piece of architecture, a software architecture, they combine multiple algorithms together. So imagine if you have 70 to 100 algorithms, the number of combinations you're going to get of that are significant. So in terms of what kind of innovation we're going to see in computer vision in terms of the video and the images that we see, it's really open, and it really depends on the engineers and the data scientists that are building, or the team, broadly speaking, that are building it. What do they want to get from this sort of computer vision machine learning exercise? Having sort of outlined how much progress has already been made in the science side of things and the engineering side of things, I'm going to start applying this now. I'm going to start applying it to things that you might have heard of. So actually, I'm going to switch over to chat, and I'd like to find out a little bit more about how much awareness you have about this space already. So I'm going to throw out some names there of things that you might have come across or you might have heard of. And if you could just show me an emoji, a hand or a smiley face, if you recognize these names. Detectron 2. Okay, so I'm going to wait a few seconds. Have you heard of Detectron 2? It's an algorithm. You may or may not have heard of it. I'm not seeing a lot of movement here, so I'll move on. So no to Detectron 2. Have you heard of Portal? It's a device. Anybody heard of Portal? Are you seeing any smiley faces there? No smiley faces. No hands. Okay, so let's move on. I don't have the logo here, but who's heard of Facebook? Okay, so I can see some responses coming there. Right. So Facebook, yes, the social media platform, is a maker of this device that you can see on the screen here. It's called Portal. And the algorithm that I mentioned earlier, Detectron, is also developed by Facebook. It's actually an incredibly powerful algorithm. And I'll be giving an overview of what that algorithm does to give you an idea of what is actually possible these days with computer vision and machine learning. So Portal is actually an electronic device developed by Facebook, and the idea behind it is that it's for communication. So it's a tablet with a really powerful camera module on it, and Facebook says that you can use the device to keep connected with your loved ones, keep remotely connected with your loved ones who might live far, far away, and some of the benefits of it, or sort of the real technical complexity in terms of computer vision, come from a tracking algorithm called Detectron 2 that Facebook developed and is using in Portal. What the tracking algorithm does is, if you imagine there's like a family scene, and you're using Portal, and on Portal the camera is looking at a family of like 2 or 3 people, and you've got a wide angle view of those people. If one person moves off to the right, they might not be in the frame anymore, so the viewer might not be able to see them anymore. What Facebook has done with its algorithm Detectron 2 is it's implemented person recognition and person tracking, so that if the person were to move off the frame, the software would track them, and the viewer would still be able to see the person as if they were in the frame. I'm actually going to give a demo of Facebook's algorithm, but not in the Portal. It's a video that Facebook recorded themselves. And then I'm going to go through some of the specific things that the algorithm is doing. Again, just to give you an insight into what is possible what has been possible, because this algorithm is now old, things change very, very quickly in this space. Every 3 months, something new is going to happen. And this algorithm probably now is about 2 years old. So I'm going to switch to sharing my screen so that you can see some video. And so here we are on the Facebook page. I am just going to zoom in a little bit here. So I'm going to pause this video and I'm going to begin from the start. I'm going to actually. So what you're going to see here is basically wide angle video, and then you'll see some items being identified as some things that are happening. I'm actually going to speak over the video as the action happens to describe what's actually happening here. Okay, so it's a kitchen scene. Okay, and here, okay, so here we've got object identification and labeling. So you've got boxes appearing around different things in the kitchen, and the algorithm is identifying what those things are. And you see a percentage mark next to it, and that's how confident the algorithm is that it's identified a potted plant, for example, at 94%. And as you can see, the accuracy, well, its stated accuracy is quite high, but if you with your own naked eye, you can see that that is indeed a plant pot. You can confirm that is a plant pot, and we've got a microwave there in the background. So this is called object identification and labeling. And so this is something that we've been able to do for years now. I imagine we are going to see more and more of this type of algorithm being used for advertising, for example, customized advertising. And I'll sort of give a use case of that. Imagine you're watching on your TV, or it's being streamed to you, a football match. In a football match, they usually have advertising boards around the pitch. So imagine you are streaming this football match on your laptop, and the platform that you're watching on already has some information about you, some demographic information about you, so it can profile you a little bit. So what could happen here is with the profiling information, the platform that you're watching on could deliver to you adverts on those boards that are custom to you. So the computer vision would be used to identify a place on the board in the football pitch where that advert or the logo would go. That way, so in a pitch, if we say that there are, 15 advertising boards available, and each one of the boards is labeled, the algorithm can detect which board is best for to display a particular logo or a brand that is relevant to that sports enthusiast who's watching that match. So activities like that, I think you will see more and more of. Okay. So a little bit more labeling here. And so we've got person detection there as well. And here, look, we've switched to something slightly different. Well, very different here now. So what you see here is like a skeletal structure of the person. This is called pose estimation. This is very good for both tracking. As you can see, that skeletal structure, that stick drawing, it follows, it's superimposed over the person, right? So in this way, you can track the person as they move right and left. And of course, this is what Facebook Portal was using to track the person right and left when they were, in the portal call with somebody. But with this stick person, you can actually see there are certain points in the stick that will sort of bend. And this kind of computer vision analysis could be used for, I imagine, in sort of clothing outlets where they're trying to figure out if you are virtually applying clothing to somebody, trying to figure out what part of their body is actually visible. So with pose estimation, you can see if there's one leg or two legs, or if the leg is bent, if the arm is bent. So it could have that kind of use case or that kind of application. Something that I've seen that's already incredibly popular is actually not strictly to do with marketing, but who knows how a creative marketer might sort of try to implement this. But things like exercise videos and training people on how to move their body. So this kind of algorithm would be incredibly useful in that space. And as you can see, it's really, really accurate, and we've had this for a couple of years now. So this is pose estimation. And we're moving on to a slightly different space now. And I think there's going to be a better example of this. Okay, here we go. So here, you can see the labeling. The labeling is still here. You've got your microwave, and you've got your clock, and you've got cups there, and you've got a person there. But you also see, this is called segmentation. So what the algorithm is doing is drawing a sort of a border around the edge of things, right? So you can see the edge of the potted plant, you can see the edge of the cup, and it's basically filling in what it thinks is the entirety of that cup. So in the foreground, you can see that pink cup there. So the algorithm thinks that everything that's shaded in pink is one cup, and that's called masking, and this is all done automatically. So again, this masking use case, it could go back to kind of heavily customized advertising, where lines can be detected, and once you've done the detection, then you can run further algorithms to perhaps even remove the cup. So you see that cup, the pink cup in the foreground, I've detected it. So then I can try to develop another algorithm to completely remove that pink cup automatically. So all you see is the kitchen table, or I could try to replace that pink cup with something else, like a plate. So there would be 3 different algorithms, but you would sort of build them together into an architecture that helps you to, 1, identify where is a pink cup, and then 2, replace a pink cup with a plate. And so in marketing terms, you might find that, okay, where is the make? So, if you know that there's a male viewer who's highly not interested in makeup, what you could do is, where is the makeup brand or logo? Replace the makeup brand or logo with something that this male viewer is more likely to be interested in buying or learning about. So that's how these algorithms could be applied. Or actually, I have heard that they're already being applied. I haven't seen them in action, but I have heard research into this space already. So you will see these products and services come out soon. And you can also see tracking there. So that is lovely. Did you see that? So, obviously the people are colored. So that's your, that is your masking, and then the masking is tracking people around, and that's your Detectron 2, and developed by Facebook and available in Portal. And Facebook is possibly using this, Facebook is certainly using parts of this algorithm in other products. We just don't know about it. So just moving back to, so here we are. Okay, and just to give you a static image of what we saw there, here again we see several things happening here. Actually, we see labeling. We see, if this was moving images, you'd see that these people are actually being tracked. So tracking. Tracking is actually quite a challenging task to have to work with. Using computer vision or machine learning in still images is one challenge. Using computer vision and machine learning in moving images in video is another challenge, because you've got so much more data to deal with. And of course, with movement, of course, the pixels are going to change, but significant things that like the light and the sort of the light conditions will change, but how clearly visible a person is also change. So right now, for facial recognition, my face is visible, right? But if I were to, so I made a movement there. Now you can't see my face, so facial recognition is not going to work. And so in movement, there are these challenges to take care of. If the face isn't visible, what are you going to do? Will you fall back to pose estimation and try to look for a body instead, which is a task that's done? So you have several things happening here, which is not surprising. So you've got segmentation. You can see the background. We've got the sky, and then we've got the trees. So the background has been separated from the foreground, and in the foreground, they've labeled people and bicycles and a flag and other things. So here again is your pose estimation, and look how accurate it is. It's certainly with the foreground figures, where people's limbs are clearly visible. You can see the pose estimation kicking in there. And this again is labeling. So this basically puts a box around the object rather than drawing a line around the edge of an object. So drawing a line around the edge of an object is obviously far more accurate and a far more sophisticated task. So that's my quick introduction to, and this has been very, very quick, to some of the advances in computer vision, machine learning, and how they've been applied to the visual space in a product that has been out in the market, not as successful as Facebook had probably hoped for it to be, but certainly been out in the market for at least 2 years. So now I'm going to move on to on the scale of visual aesthetics, something that is on the higher end of that scale. And some of you may have heard, or so basically, in the last few years, what we've seen is a lot of innovation driven by creative people, and Fabricant is one such example. It's basically a design house that is purely designing, so it's a fashion design house that's purely designing outfits, clothes, digitally. They don't do real life design. Everything is digitized, and they use a mixture of their own skills in digital design using existing software applications with some computer vision enhancement to help them think creatively and collaborate internationally when it comes to designing their clothes. So let's have a look at some of the things that we're seeing these days. And so here, what I really wanted to show in the digital space, in imaging, and some of you might know this already, it's what we're trying to do is recreate what a human eye sees. And we need a fair amount of detail, and we need those creases, the texture of the clothes. We need the light to shine in the right place. We need the shadow to appear in the right place. And all of these details add to the overall visual aesthetic of the picture. And here, the visual aesthetic of this outfit, and help us decide whether we like it or not, right? If we can see it very clearly, if we can see it in detail, it gives us a better idea of whether we like it or not. Then imagine this outfit on a 3D generated model. Not a real model, not a human model, but a 3D generated model. So then you have movement as well. So then you can see when the fabric creases in places, and how the fabric falls over a body, how the fabric moves when the wind blows. So all of these things. So, if you were to go into a shop and try on an outfit, you will move around, you will swing around to see how the outfit or how the clothes sit on your body. This can all be done in the 3D digital space now. And some of the more impressive stuff that this company has worked on includes, they've actually worked with companies like Puma, and this is Puma's, I forget, this looks like an autumn collection. It's autumn collection for Puma, the sports company, and this was purely done in a digital space. These clothes were not manufactured. And because it was done in a digital space, it allowed for international collaboration. People didn't have to travel with huge suitcases and lots of clothes and fabrics to a different location to design these outfits. All the collaboration was done online, and because we had the tools that are sophisticated enough and the compute power sophisticated enough to allow us to do that. So with these particular clothes, it was more a task of generating very detailed, very lifelike right, lifelike images of the clothes and these sort of mannequins that they sit on, and these mannequins do actually move. Let me give you an example of again, this is the same company, and they have also started to experiment with stimuli that they use for creating their digital outfits. So here you see 3 images, and on my left, you will see a lady in a white outfit, a model in a white outfit on the catwalk. So this is a real life model on a catwalk, and I just realized, no idea how that happened. What the company did was it got a database of such images, and it did a whole bunch of machine learning, and they used an algorithm called a GAN, an adversarial network, to create something different, to bring together the images that the algorithm had been trained on to create something different. That's what you see in the central picture. So then the output of that algorithm was just a combination of the different outfits that it had seen on the catwalk. Some people are calling this predictive fashion, predicting what's going to happen in the future, but I don't think it's predictive. Fashion moves on different trends. It's not, a combination of things that we've seen in the last show. And so you see the central picture, it's slightly fuzzy, but that is what the algorithm threw out. And then the final picture, you see the designers then use that central image as impetus for creating their own masterpieces. And so just looking at some of the other work that they have been able to do. So here again, this is Puma and footwear, and this is purely digitally created footwear on the one hand side, and then you can see the entire outfit on the other hand. And so just to give you an idea of how popular this sort of digital fashion is becoming. So that was... there was a digital outfit that last year sold for $10,000, and it's a purely digital outfit. It was never made. It just exists in the digital space. It looked very nice, and it was bought for $10,000. So you have digital fashion design, and then you have digital models that are going to model the digital fashion designs. I think this kind of innovation is helping a great deal with sustainability, with collaboration, with creativity. So with that collaboration comes creativity, but also with AI, you can get creativity. So if you were to use a GAN, adversarial network, you can sort of throw images together and see what kind of output the algorithm is going to give you. It might look horrible, but certainly the algorithm is going to think, specifically these GANs are designed to kind of compete one set of images with another set of images. So these competing ideas. So it's certainly going to output something that you might not think of, because it's going to have very blue sky. It doesn't have limits to its creativity, right? And some of it will be rubbish, but some of it might be really interesting. So other things, I can see that I'm running a little bit low on time now, so I'm going to move quickly through some of the other innovation that we've seen. And of course, working in the video space, we're all very familiar with Adobe, and Adobe makes some amazing technology. And with the video, you've got Adobe Premiere Pro. You may have seen this feature rolled out already. But here, I don't have the video for this, but I do have slides. So you have this scene of the road, and you've got this red car and a cyclist. Imagine. And so this is a video clip. So you cannot edit the red car out in Photoshop. It's video. So how do you edit out the red car? And remember how I said that working with moving images is far more complicated than working with still images, because over here you can see, look, so on the ground you've got texture, right? The car has a shadow. The lighting is, lighting is directional. So you have to consider all of these things with frame by frame by frame by frame by frame by frame, because that's what video is. So in this exercise, imagine you want to remove the red car from this path. With computer vision machine learning, Adobe have been able to identify where the red car is. And so they masked the red car, and they essentially deleted the red car. And then they have other algorithms, and these are also available in Photoshop to some extent in terms of the clone tool. What Adobe Premiere did was it looked at the grainy road that was beside the car, and it ran an algorithm on that kind of grainy texture, and it figured out, well, what kind of grainy texture could replace the car? And lo and behold, they created that grainy texture to replace the car. Now, of course, this grainy texture is quite, there's a similarity across the path, right? And so this was a slightly easier exercise to do. If there was something that was heavily patterned, and you were trying to replace something that was heavily patterned, or kind of patterned in a way that's where replication, we're merely copying it across, is difficult, then that's going to be challenging. Moving on to some other things that have really come of age now. So some of you may have seen Tom Cruise's deep fake. So deep fakes are something that we first got to see a couple of years ago, actually about 3 or 4 years ago, with that video. Somebody had deep faked Barack Obama. And that was scary. And you could see that it wasn't real. Let me play you this Tom Cruise video very quickly, and you can see how realistic this video is. Okay, so it was originally shown on TikTok, so obviously the aspect ratio here is going to be for TikTok. And now I have a horrible ad.
This is a switch bike. No.
Okay, so let me just... So this is a deep fake. So this is artificially generated. This is not Tom Cruise. So body movement, finger movement, lip movement, eye movement, facial expressions, how he's smiling. Okay, he put his hair through, he put his hand through his hair there. So let's just, I think this is quite a realistic looking deepfake of Tom Cruise. And there are some other videos as well. And this is available on YouTube if you'd like to see more of that. But what I really wanted to cover here is that.
Or for the audio experience.
Sorry, excuse me, just need to pause that. Right. What I wanted to cover here is a comparison between what the model who did that deepfake looked like. Well, he's an actor actually. What the actor looks like and the actual what Tom Cruise looks like. And you may remember seeing this picture just slightly earlier. So on the one hand, you see the image of Tom Cruise. On the other hand, you see the image of the man who made the deep fake. And actually, they look very similar. So in terms of the algorithm trying to superimpose lips, lip movement, eye movement, it's not going to be an incredibly challenging task here. That's part of the reason why I think that deep fake looks very realistic. But if you compare the lip movement and the eye movement, the facial expressions basically in this video, if you compare it, if you compare this deepfake with the Barack Obama deepfake, this deepfake looks a lot better, and that gives you a sense of how fast things improved. Okay. So again, with deepfakes, I see their use case being, for fun. Deepfakes always are a little bit, so they're also referred to as synthetic media because it's made up. they're always a little bit disconcerting. And how sort of people respond to them as the years go by, is yet to be seen. They like many other things, they might become more and more acceptable as the years go by. But certainly a use case for deepfakes now, or sort of in the near future, is training material, where you might use a mannequin or like a 3D generated humanoid to show something. You may as well just use a deepfake in its place. The two things are going to be very, very similar, and it's going to be a point of preference, or your own sort of business use case that's going to help you decide which is better to use. With deepfakes, the other thing to note is, this idea of everything being virtual and not really existing, or it being digital and not existing in real life. We're already seeing digital vloggers. So here, for example, this is Miyamoto. She is a vlogger on YouTube. So I'm assuming that this vlogger can dress herself. This digital vlogger can dress herself or using some of the digital outfits designed by the digital design house I mentioned earlier. So we're moving into sort of a very sophisticated existing in a digital space, especially where the fashion industry is concerned. And of course, visual aesthetics are incredibly important in fashion. So, where there are big movements in sort of the fashion space, it means that we've been able to overcome some really, really big challenges in how we try to recreate real life things. For example, clothes. Fabric have always been difficult because of texture, lighting, and things like that. But it seems like we're getting to a place where we can now overcome that. Finally, there are companies like the one that I work at, Cerebrum Studio. And we basically, we do a fair amount of research looking at machine learning and computer vision, but we think very carefully about how it's going to be applied to real life situations. So some of the things that we work in look at helping people who work in social media and who manage multiple social media platforms, how to help them compose images. And so, yes, we also work with algorithms similar to what Facebook developed. So we help to compose images based on facial recognition, and help to track images. So, if the person were to move right and left, for example, the frame that you've composed wouldn't be lost. And of course, dealing with aspect ratios and different frame sizes for different social media platforms. So we deal with the square and the landscape and the different vertical sizes of aspect ratio as well. So finally, what I'd like to leave with is vision science is already delivering quite spectacular results. So that's in technical terms. So if you're a technical person, if you're an engineer, you're going to absolutely adore, or you're going to feel very, very happy with the kind of work that you're doing, because technically speaking, it is really, really, really impressive. But the question is, who will engineer truly useful products for the marketing community? So the who bit becomes really, really relevant here. And so I think the best innovation is coming out of teams that are collaborating. Excellent. I've been told that I can speak a little bit longer and actually have a Q&A session. I was running out of time. Thank you. So I think it's going to be teams that bring together the sort of creative aspect. So people that work in the marketing communications profession who have first-hand experience of, what kind of visual aesthetics are required, that work with an engineering team, either internally or collaboratively with different companies. So the two sort of buckets of expertise are brought together. So you have your engineering expertise and you have your creative expertise, and that kind of team is probably going to build the best products, best marketing products using computer vision and machine learning. So some of the things that I've touched on in the examples that I showed earlier, and we will see more and more of, we're looking at automation to remove redundancy. So the Premiere Pro is a good example of that. So they automatically removed the background so that you didn't have to painfully, well, you can't, well, if it was a still image, you'd have to use a clone tool to painfully clone the car out using the surrounding pixels. But this is done for you automatically in the vision space. In the moving image space with a new tool that Adobe Premiere have brought out. Of course, automation to remove redundancy is something that we look at in Cerebrum Studio. So in terms of aspect ratios, if you're dealing with multiple aspect ratios, then you should be able to create the multiple aspect ratios at the touch of a button and not have to kind of edit one video, a square video, and then a landscape video, and then a vertical video, one video at a time. So we've got rid of that repeat actions, and we've automated that, and you will see a lot of that as the years go on. Then we've got emotion recognition based marketing. So, you've seen that facial expressions we didn't see the labeling of facial expressions, but actually emotion recognition is pretty sophisticated these days. So you will see more marketing that is responding to people's emotional or kind of facial emotions on their faces. We'll also see more with IoT, because there are devices around us, it's, we'll have like a multimodal experience of marketing. So it'll be more experiential. And because of IoT, because of the devices around us, there'll be multiple touch points, but the point here is that it'll be more experiential. So, being able to control lighting and temperature and sound, it'll make you feel something different, right? So we're going to see, and once we get a handle of how to control these things together in a way that people are happy with, people are going to see, music is a great idea, right? So, you might already have like an Echo or Siri you use to play music, and so you might want to set the mood, so then your lighting changes, and there's like an emotional response to all of these changes around us. Music is nice in the way that we want it, the lighting is nice in the way that we want it. Maybe even if you want to change the temperature, you could do that quite easily. What's on TV, so everything around you can be changed to match your mood. So personalized visual marketing, I touched on this at some length earlier on. So being able to identify, having some data about the individual that you're targeting and using that data to customize the branding that they see. Of course, because a lot of this innovation is digital, it can happen remotely, and people can connect with one another over the internet, and there will be a good deal of international collaboration. Actually, a lot of these fashion houses are already collaborating internationally. Some of them are based in Europe, and they've done collaborations with companies based in different parts of Europe and in New York, for example. And that's been great during this lockdown situation. It would have been impossible otherwise. Of course, AI will also be used to boost just creative stimuli, really, just to kind of bring different data sets together. And just there's also, I talked about GANs, but there's also style transfer, where you can take the style of one thing and apply it to another just to see what it looks like. And if you can do it at the touch of a button, and that's a great thing, right? So the amount of resource that you spend on experimenting with what that might look like is so little that it's really worth it, just for stimuli, just for creative stimuli. And so that ends my session. I have gone over time a little bit. I hope that has been okay. But does anybody have any questions for me? And of course, if you'd like any further details on things that I've mentioned, I'd be happy to email things out at a later time. So just email me and we can sort that out. Any questions? Okay, and so while people are writing things in, I will add that, of course, feel free to follow us on any of our social accounts. And of course, if you are interested in dealing with the challenge of multiple aspect ratio video content creation in an easy way, please do follow us, because we will be launching our application in summer. So you'll get to see some of the technology that we've been building. And so we're a team of creatives and engineers that have come together. So I used to work in video production. So we've been able to identify what are the real barriers, headaches is a better word. What are the real headaches in video content creation for social media? And we've built Room Studio in response to those headaches. And so having built the application and use computer vision and process automation, what we're really trying to do is remove the technical complexity so that users are free to create and be creative. So you can focus on the content and the messaging rather than have to worry about technical specifications, looking at aspect ratios and resolution and bitrate and these sorts of things. So do connect with us if you're interested in learning more. So we have a questionnaire. So why video matters so much these days? Okay, so it's just a far more engaging medium, and it's quicker to get a message across. I think generally speaking, the big trend that we've seen on the internet is that there's just so much data available to us that our attention span is significantly reduced. If we don't, if the information or the blog or the vlog or any material that's online doesn't engage the viewer in the first 3 seconds, they've lost the attention. Video is in a really good space to deliver quite a lot of information in those initial 3 seconds. So in terms of engagement, it's going to be the engagement rates that you see with the video are going to be far higher than what you see on, say, like a standard written blog with words. There are other things with video, especially with advances in computer vision that we've seen. We can, we used to use After Effects and 3D animation to create things that didn't exist before, to give users a visualization of what something might be like. For example, furniture. And kind of placing furniture around your room to see how it would look. So we'd kind of 3D generate that image. But with virtual reality and the kind of advances, again, that we're seeing in GAN, we don't need this sophisticated software to do that. You can just run it on your application. So, creating things that don't exist just to give a viewer some idea of what it might look like, it's quite tantalizing, really, isn't it? So you've got that in the one use case where it's about being useful. How do I build a chair? Well, here's instructions in a video, in a 3D video. And then there's kind of being able to generate worlds that don't exist, that are just for us to look at, because they just, the difference is just creative. And this is falling into the whole fantasy, sci-fi area of video. And of course, this is quite popular. It has been quite popular on TV in terms of videos that we stream from Netflix and Amazon. Where we are taken to different worlds. Worlds are kind of 3D generated. So that's a second use case to kind of visually create something that just doesn't exist, either because it's useful to show somebody a visualization, or that visualization is just really nice to look at, or very different and so engaging in that way. So the thing with video engagement, how video is more engaging than text, we've known that for a while now, but I think we've seen a lot of these social media companies optimize their platforms to encourage more users to contribute video, and for the end users to be able to view that video content more intuitively. And what I mean by that is, so I mentioned aspect ratios. So aspect ratios is basically the screen size, or how much screen size the video takes on your phone. So imagine Facebook, for example, when you're scrolling through your feed. And so most Facebook users access the platform on their mobile devices, right? Most Facebook users access their platforms on their mobile devices. And Twitter is basically, a mobile app. Yes, you can access it on your laptop, but it's basically a mobile app. Then there's Snapchat and TikTok and all of these other video platforms are, mobile first, right? And so when I say companies have rushed to optimize their video content, what I mean is the aspect ratio point here. So my screen looks a little bit messy, but most people who access content on a mobile device will continue to hold their mobile device vertically. So it'll be like that. Oh, actually, I don't think you can see me anymore. But, imagine holding your mobile vertically, as opposed to turning it horizontally. What that means is if you had a traditional video on, if you access YouTube on your mobile device and you don't turn your mobile so that it's in the horizontal plane, what you will see is that the YouTube video occupies about 1/3 of the screen space on your mobile device. Only 1/3 of the screen space is occupied by that YouTube video. However, if you were to go to Facebook and you're on your Facebook feed, scrolling through videos, Facebook has started encouraging content creators to start making either 1x1 videos, so that's a square video, or a 4x5 video, so that's like a semi-vertical video. Because a square takes more space on a mobile screen. A square video takes 2/3 of a mobile screen, and a full vertical video takes the entire vertical space of a mobile screen. So this comes back to engagement, really. So not only has video been more engaging than other forms of communication, but video is also being optimized to be more engaging in the mobile space. Okay, so another question. Okay. So the question is, would video becoming a self-fulfilling prophecy in that it decreases our attention span? I think there's a lot of video out there, and I think people are being very selective on what video clips they choose to continue watching. And I think that it could be that there's a lot of video that's okay, but the user's just not interested in continuing to watch it, and they just stop watching it. I do think that people will feel overwhelmed with video, and whether it's a self-fulfilling prophecy in terms of engagement, it might just be that I've had enough of video and I don't want to watch too much of it anymore. It's like everything else, right? Too much of something will become problematic. And as I say, we're already seeing people become quite selective of what they choose to watch and choose to sort of ignore. But yeah, I certainly think that in terms of continuing to keep engagement in this space where we know that video is becoming noisy, it's about the creatives, right? You just need to make sure that, well, your sort of target market really, really well, and that you've got the creatives that really resonates with them and really makes them want to continue watching that video. Because there will be a lot of rubbish video content online. I'm sure you'll know. So another question. So what are the AI trends for speakers like Google Home, Alexa? Oops, that just moved. In the news industry. Okay, so somebody's asking about AI trends for some of the most popular, some popular voice triggered applications like Alexa, like Siri on Google in the news industry. I suppose there are platforms like Trint that do transcription. So Trint was actually developed by one of the founders of Trint. And so here's my perfect example. So Trint was founded by a former journalist who then built a tech team. And its first offering is transcription. And I believe that's a bit of a nightmare for journalists that have to kind of write out an interview. So So what it is voice to text. So it takes a voice and creates a text file. Getting accuracy in that text file has been challenging. It was challenging several years ago, but these days it is quite an accurate transcription. It's probably going to be about 90, if you're an English speaker, and it depends on the language you're using as well. It depends if you've got an accent. But these days you can get about 95% accuracy, between 95 and 98% accuracy. So the accuracy is quite good. And of course, if the application's been developed well, it will give you the opportunity to change any words that haven't been transcribed correctly. So once you've got the transcription, so once you've got the text version of your speech, of your vocal speech, of your audio file, you can translate it. So then you can have the English, and then you can have the Spanish, and then you can have the Urdu or the Arabic. You can have, so this is something that's popular at the moment. I think Trent has raised some more money to grow its offering, so you will see more and more of that. So there is another question. Like I said, that one was answered. Okay, I think I have answered those questions. Any other questions? Any other comments that people would like to share? I'm happy to be the speaker here and just talk about what people have to say. Okay. I think perhaps you've had your fill of computer vision and machine learning in the creative space. But I hope that's given you an indication of where we are in terms of technical sophistication. So we are quite ahead in terms of technical sophistication because it's been a hard task to do. It's been a hard task to do, and we've made great progress. But we're not in that space where we can generate a completely human-like image. So the deepfake that you saw with Tom Cruise, as I mentioned, the original actor looked quite a lot like Tom Cruise. And the areas that were significantly changed in the fake version of that video were the lips and the eyes. So if the algorithm is having to make small adjustments around facial features and expressions, of course, it's an easier task to do than it is to completely generate an image out of nothing. In actual fact, Adobe have done some really interesting experiments in that space, where they have actually, there's a scene of a car driving in a winter sort of environment, and then from that scene, they generated a completely artificial scene of that same car, but driving in a summer landscape. So, where there were bare trees with brown branches, and the sky was gray, and the lighting was all very kind of subdued and just down. That all changed to sort of a summer environment where the trees were in full bloom and had green leaves, and the sky was clear and the lighting was bright. And of course, with the lighting change, then you've got the reflection from the kind of sunlight, and all of these things had been done quite accurately. So that was quite interesting to look at. But if you are interested in kind of continuing to keep abreast of sort of latest R&D when it comes to imaging, Adobe Sensei, which is Adobe's AI branch, is a good. I believe they have a blog. They're a good place to keep tabs of things, as well as Facebook release some of their R&D. I'm sure Google do as well in the image space. Google have been putting a lot of AI technology into their devices. So they've got the Pixel phone, for example, and you might have seen that it does quite well in low light conditions. I don't know why you would want to go out and take photos of the sky with your Pixel, but if that's the kind of thing you want to do, supposedly it's going to give you quite good quality images. And so the machine learning behind the algorithms behind that are actually quite sophisticated, and the results of that are noticeable. There is a noticeable improvement. It might not be fantastic, but it is noticeably better. And then there's of course Nvidia. Nvidia is a chip maker, and so a lot of these, as I mentioned, we've got the compute power, the servers to do machine learning on, and these servers have incredibly powerful chips, GPUs, and Nvidia is a GPU maker. So Nvidia does and publishes a lot of R&D looking at computer vision, machine learning as well. So that would be another place to go and keep abreast of things. And then there's, of course, us. So if you'd like to know more about sort of enhancing real life video for social media, then Cerebrum Studio is an organization that you can follow. Oh yes, Trint, Trint. I'll just type that in actually. I'm just going to quickly search to make sure I got it right, but I believe. Okay, yep, that's right. So I will, unless there are any other questions, I will request to leave this session. Thank you very much for your attention. I can see most of you still stayed with me. I really appreciate that. And if you'd like to know more, just keep in touch. Okay. Enjoy the rest of the conference. Take care and bye for now.